Hello student, welcome to the course of electric power distribution and utilization. In our last class we have started the chapter that is the distribution system. Today we are going to study about the AC distribution system, then DC distribution system, and what are the requirements of distribution system. So first of all, AC distribution system, we know that electric energy is generated, transmitted and distributed mostly in a form of AC. It is because the alternating voltage can be easily changed in magnitude by means of a transformer, that is the step up or step down according to our needs. Then with the help of a transformer we can transmit the AC power at a higher voltage in order to minimize the losses, and then use the transformer to step down this high AC power to low power for the specific use. So high transmission and distribution voltage have greatly reduced the current in the conductor and the resulting line losses. So in AC distribution we have primary distribution system and secondary distribution system. So what is primary distribution system? It is that part of the AC distribution system which operate at a voltage somewhat higher than the general utilization and handle a large block of electrical energy than average low voltage consumer use. The most common use of primary distribution voltages are 11 kV, 6.6 kV and 3.3 kV. Due to economic consideration, primary distribution is carried out by three-phase, three-wire system. So primary distribution system is simply a distribution system which operates at a higher voltage than the general utilization voltage or generally we use in our home, and its voltage is 11 kV, 6.6 kV and 3.3 kV, and primary distribution is carried out by three-phase, three-wire system. Then we have a secondary distribution system. It is that part of the AC distribution system which includes the range of voltages at which the ultimate consumer utilizes the electrical energy delivered to him or her. So the secondary distribution implies 400 or 230 volt three-phase, four-wire system. So mean the secondary distribution system use the voltages that are lesser than the primary distribution system, and we mostly use these voltages in our home, that is 400 or /230 volts, and the system is three-phase, four-wire system. Then another distribution system, that is the DC distribution system, is we know that electric power is generated, transmitted and distributed in AC, but there are certain applications where DC supply is necessary. For instance, the DC supply is required for the operation of variable speed machinery, that is the DC motor, for electrochemical work and for congested area where storage battery reserve are necessary. So for this, AC power is converted into DC power at the substation using converting machinery. In this converting machinery we have mercury arc rectifier, rotary converters, and motor generator sets. So there are some applications where we need DC supply, so AC power is converted into DC at the substation with the help of different types of machinery. Then in DC distribution system, as in AC we have primary distribution system and secondary distribution system. Similarly, in DC we have types of its types. The one is two-wire DC system and the other one is three-wire DC system. So the two-wire DC system, as the name implies, this system of distribution consists of two wires. One is the outgoing or positive wire and the other is the return or negative wire. The loads such as lamp, motor, etc. are connected in parallel between the two wire is shown in the figure. This is the two-wire DC system. The one is positive or going and the one is the return or negative, and the voltage across them is V, and we connect the load like light or lamps or motors across it in parallel. So this system is never used for transmission purposes due to the low efficiency, but may be employed for distribution of DC power. Then we have a three-power DC system. As the name suggests, again, it consists of two outers and a middle or neutral wires. We have three wires, which is at the substation. The voltage between the outer is twice the voltage between either outer and neutral wire as shown in figure. So this is the three-wire system. We have two positive and negative wires and one neutral wires. So the voltage across this positive or neutral wire is V, and also the voltage across this neutral and negative wire is also V, but the voltage across positive and negative is 2V. So mean we can connect heavy load across here and low load across here. So in this way, two voltages are available at the consumer terminals, that is V between any outers and neutral, and 2V between the outers terminals. Load requiring high voltage, example motor, or connected across the outers, that is the positive or negative, whereas lamp and heating circuit require less voltage or connected between either outer and the neutrals. And then the requirement of a distribution system. We need a proper voltage. One important requirement of a distribution system is that voltage variation at the consumer terminal should be as low as possible. The change in voltage are generally caused due to the variation of load on the system. So the voltage variation, the allowable voltage variation is plus minus 6% of the rated value at the consumer terminal. Thus, if we using a voltage of 230 volt, then the highest voltage of the consumer should not exceed 244 volt, while the lowest voltage of the consumer should not be less than 216 volt. So this is the requirement of a distribution system. The first one is that proper voltage is available at a consumer terminal. Then the availability of power on demand. Power must be available to the consumer in any amount that may be required from time to time. For example, motor may be started or shut down, light may be turned on and off without advance warning to the electric supply company. So as electrical energy cannot be stored, therefore the distribution system must be capable of supplying load demand of the consumers. So the next requirement of a distribution system is the availability of power on demand. The next one is the reliability. Modern industries almost depend on electric power for its operation. So home and office buildings are lighted, heated, cooled and ventilated by electric power. So this call for reliable service. Unfortunately, electric power, like everything else that is man-made, can never be absolutely reliable. However, reliability can be improved to a considerable extent by using the modern techniques like the smart grid techniques and standby generator and integration of the distributed generator in the power system. So these are the requirement of a distribution system. Thanks for watching.